Welcome to my presentation.
Hi, good day. My name is Malus M. De Los Reyes, a third-year BLIS student.
For today's video, we are going to discuss the Chapter 9, which is the analysis of data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data so that the reliability of conclusions based on the data may be evaluated objectively in terms of probability. There are two major areas or types of statistics. These are theoretical and applied. The former is concerned with the mathematical aspects of statistics, and the latter involves the practical applications of statistics. Role of statistics. Generally speaking, statistical analysis may be used to accomplish four basic purposes. In short, its basic purpose is to summarize observations or data in such a manner that they provide answers to the hypothesis or research questions. Cautions in using statistics. In addition to keeping in mind that the statistical analysis cannot do the interpretation, the researcher should be aware of other concerns in using statistics. Steps involving in statistical analysis. The establishment of categories. The four basic rules or guidelines should be followed. Coding of data. Once the categories have been established and data assigned to them, it is necessary to convert the new data or responses to numerical codes so that they can be tabulated or tallied. One of the most important considerations in coding is reliability. Problem-solved reliability in coding can result from inadequacies in the data. Analyzing the data. Descriptive statistics. Once the data are ready to be analyzed, the researcher can choose to utilize descriptive statistics, inferential statistics, or both. Looking first at descriptive statistics, which have been the predominant type of data analysis employed by researchers in library and information science, there are at least 6 basic functions that they can perform. These are generally referred to as correlational or associational statistics. They have the ability to allow prediction of one variable based on another, but they cannot use to establish causal relationships. Another type of correlational statistics is the cross-tabulation or bivariate frequency. These are the products of tables in which two variables have been cross-classified. In contrast to descriptive statistics, which simply summarize and describe the data as indicated on the previous slide, inferential statistics, on the other hand, can perform certain more sophisticated functions. They are most commonly used to predict or estimate population parameters or characteristics based on random sample statistics and to test hypotheses using tests of statistical significance to determine if observed differences between groups or variables are real or merely due to chance. In short, inferential statistics help one to make inferences and judgments about what exists on the basis of only partial evidence. It should be remembered that statistics are used to test the null hypothesis or the hypothesis of no relationship, as opposed to the research hypothesis, which does predict a relationship. Null hypotheses are necessary in order to avoid the fallacy of affirming the consequent. Parametric statistics. Parametric statistics require the assumption of a normal population or distribution. When the data of a normal distribution are plotted on a graph, they should produce a curve that is symmetrical and unimodal. Its mean, median, and mode should coincide, and there should be a constant area, or proportion of cases, between the mean and an ordinate which is given distance from the mean in terms of standard deviation. Parametric rests are relatively powerful, or likely to detect a difference between groups if a difference really exists. In other words, the power of a test is directly related to its ability to eliminate false null hypothesis. Power may be defined as 1 minus to the probability of a type D second error. A type D second or beta error is the error of failing to reject a null hypothesis when it is actually false. A type D first or alpha error is the error of rejecting a true null hypothesis. When the probability of one type increases, the other decreases. Some examples of frequently used parametric tests are the following. Z-test tests the difference between a group's results and the results that would be expected due to chance alone. Student's t-test, a test that can be used in place of the z-test where there is still only one group. The standard deviation of the population is not known. Difference of means. Analysis of variance. Post hoc tests. Reliability coefficient. Pearson's product moment correlation coefficient R. Regression. Non-parametric statistics are considered to be distribution-free, as they involve weaker assumption of population and therefore are often used with smaller samples. The level of significance is the probability of rejecting a true hypothesis. It is usually set at 0.05 or 0.01, which means that the null hypothesis is to be rejected if the sample results are among the results that would have occurred no more than 5% or 1% of the time. The 5 common examples of non-parametric statistics are chi-square test, Mann-Whitney U-test, Wilcoxon sign test, Spearman rank order correlation Spearman's P, Kruskal-Wallis test, selecting the appropriate statistical test. Statistical analysis software products are specialized programs designed to allow users to perform complex statistical analysis. These products typically provide tools for the organization interpretive. This is where my presentation ends. See you on the next chapter. Bye.